Wow, would you look at yourself right now, internet friend? You're amazing. You didn't quit after the first day of Math 3. You're amazing. Let's keep this up, friend. You're learning. Congratulations. Solving equations. This is like part 2, day 2, whatever. Yeah, good stuff. Let's do an example. And I'm just going to show you kind of some trickier-ish problems, licorice problems. That'll be good. Of things that we can do. Let's consider this example here. What if I've got 2x minus 1 in parentheses, all divided by 3 equals negative 5. That was a 5 that I was going to say. 5 sounds good. All right. So for this particular variable x, you notice that I've got 3 things occurring to it. Could someone describe to me what the 3 things are and what order they're happening to x in? So it's multiplied by 2, right? Bam, that's the first thing that happens. Then what happens? Then it's subtracted by 1, and then divided by 3, right? Rough day for x. 1, 2, 3 punch going on right there. Or 2, 1, 3. Am I right? Classic. So we want to undo those things kind of in the reverse order. So what should I undo first, and how could I do it? What do I have to deal with? Well, I'm undoing things, so I'm kind of... I have to deal with this 3 first, right? Because if I tried to like add 1 to both sides, this 1 is all like locked up inside the parentheses like some sort of tower, and I gotta slowly like access my way there. All right, there we go. So to deal with this divide by 3, I think I heard someone suggest multiplicado. Right? And I would get 2x minus 1 equals negative 15, right? And now you guys are masters from here, right? You can just, bam, cruise through this. Beautiful. And then divide by 2. And you see how my equal signs are all kind of like nicely-ish lining up. And I've got all my work showing 1 step at a time. And wow, it's a thing of beauty. X equals negative 7. And technically, if I wanted, I could do a formal check where I can check my algebra with arithmetic. If I plug this into the original problem for x, I can verify whether or not this works out. 2 times negative 7 minus 1. You don't have to write this check down, but I just want you to see the concept of it. Bless you. Is that equal to negative 5 is the question. So this is like a question mark here. Is it? Or is it? Right? And now when I'm doing a check, I don't want to use any algebra. So I don't want to start by multiplying both sides by 3, because what if I do the same algebra, repeat the same mistake, and then falsely confirm that I'm right? Right? Like, I don't want to do that. So I'm just going to do straight up arithmetic. So let's do just order of operations. The first thing I would do here is the multiplication by 2. So 2 times negative 7, negative 14 minus 1 over 3. Then I do subtraction. That's negative 15 divided by 3. And divide that, and I get negative 5 equals negative 5. And what do you know? It works. Cha-ching! We can be proud of ourselves because our arithmetic confirmed our algebra. Yeah, people usually like my little check marks. If you want, here's another one. Bam. Look at that. Well, I think it's a little long on the tail, to be honest. But it's okay. It's okay. Take that away. Save that one for later. So, all right. So there's kind of like an example with 3 things going on. I think I have 2 more types that I want to do. We're just going to cruise right through these and then let us do a party quest. Oh, were you still writing that down? My apologies. Okay, my apologies. No problem. No problem. Rewind the video. Right? And like, bam, it's good. You were trying to get the perfect check mark, and like you'd like write it and then erase it and then write it and then erase, right? I know how it is. I know how it is. Let's see. Oh, by the way, once again, like if you guys wanted to use 2 different colors for notes or more, I'm a fan of it, guys. I'm telling you, I'm a fan. Color is a beautiful thing. Let's see, here's an example A. What if I've got negative 3 times 2x? Man, I always use the same numbers. I'm so pathetic. My imagination is limited. Plus 12, and then, oh, how about this? Minus x equals 1. Bam. Now, some of our logic is a little bit limited. For instance, if I said, what happened to x today, that would be a little bit harder to describe. Because you'd say, well, there's 2 versions of it, so that's a little bit confusing. But maybe you could say, I don't know, x got multiplied by 2 first, and then it got added by 12, and then it got multiplied by negative 3, and then it got in a fight with its, like, evil twin, and subtracted itself? I don't know. That'd be weird. But the idea is we're just going to simplify first before we solve. Okay? So we're not going to start moving things around. Technically, if you're fancy, maybe you could pull some of that off, but in this case, we're going to simplify first. What's the first thing you think we could do to simplify this? Like looking at this left-hand side. What would you do if I asked you to simplify that? Yeah, let's distribute, right? I like it. And am I going to distribute like this? No. Just to the first 2, right? Everybody in the parentheses, multiplication is distributive over addition. All right. If I had 3 things in the parentheses, then go right ahead. But this guy, he's not part of the club. Don't let him fool you. Negative 6x minus 36 minus x equals 1, maybe? Mm-hmm. Now what could you do to simplify?
Add the x.
Well, okay, really important question right here. Negative 6x minus x, is that just negative 6? Do you see why people would say that? Bless you. Right? Yeah, that is like really tricky right there. All right? But that's not the case. What do you think it actually is? Negative 7x. All right? So when you combine like terms, you simply add or subtract their coefficients, but the number themselves or the variable itself stays unchanged. Okay? So that's something to point out, worth seeing there. So that's negative 7x minus 36 equals 1. My equal sign's got a little bit of a squiggle there, but that's good enough. Now what should I do? Oh, you guys are masters at this from here on. Yeah. Yeah, add 36 to both sides, and I bet you guys wouldn't even fall for this one anymore, right? You wouldn't fall for this little, right? None of you would make this mistake anymore, right? Right? What do I actually have to do to both sides? Divide. You guys, you got this. You got this. You're going to be master algebratricians. Maybe x equals negative. I don't think that divides it evenly. I'm just going to call that 37/7. Bam. Golden. All right. So the general approach here is simplify, then solve. Right? Sometimes there are problems in life that are a little too complicated. You got to simplify your life, Jacob, and then you can solve some of the problems you've got going on. You know what I'm saying? Right. I mean, seriously, just stick that in a fortune cookie right there. Let's see. I don't think I could draw a fortune cookie if I wanted. That's kind of like just like a Pac-Man. I don't know. There you go. Bam. Simplify, then solve. Bam. Crack that open. You got that. Right there. It's a sad-looking fortune cookie. It's sad. All right, last example today. So once again, same instructions, solve. Tell you what, we're even switching the variable up. Let's not use x. What's a good letter to use?
7, 5, 6.
5?
Oh.
I'm looking for variables here, but that's okay. N. N's a good one. Let's have 3n, because I think every problem's had a 3 in it so far. Minus 1 equals, let's do 5n plus 6. Huh. Well. This one's a little sneaky.
Would you add 9 to 6?
You could, but the question is that actually helpful yet? I don't know. Yeah, how do I do that?
Minus 3n from 5n?
I actually like that suggestion very well. Often we like to have our variable on the left. But I'm a fan of bringing the little guy to the big guy. Bring the little variable to the big variable. All right. How do I move a 3n? Have we had to move one of those things before? That's... Yeah, if it's a positive 3n, one way to move it is subtract 3n from both sides. I think that works. And we'd have negative 1 equals... Now these combine like terms, just like we did earlier. So I'm going to just combine the coefficients and the variable stays the same. 5 minus 3 is 2n plus 6. And bam, we are masters from here on out. Subtract 6. Negative 1 minus 6, is that what? Like negative 5? Ooh, you guys got me. Man, I can't stump you guys. Becomes more negative, right? That makes sense. It's like borrowing $1 and then borrowing $6. You don't suddenly have less debt, you had more. Am I right? And then divide by 2. And watch this. Look out. I'm going to do a flip. Bam! I flipped. You didn't even see me. And now actually if I wanted to do a formal check on this, you would actually plug this into both locations and use your arithmetic and verify that it all works out. But I won't make us do that right now. So, good stuff. Thanks everybody. I think we're good for now. We're going to do some party work now. Party!